All right. It is Wednesday, November 20th. Next week is Thanksgiving. Semester's coming to the final stretch. The year is coming to the final stretch. Lots of stuff going on. We have a great guest today, but before we get rolling, let's have our own John Sibley Butler play some music.
People say I'm the life of the party because I tell a joke or two. And although I may be laughing loud and hearty, deep inside I'm blue. So take a good look at my face. My smile looks out of place. If you look closer, it's easy to trace the tracks of my tears.
Woo! Well done, well done. Well, the weather has cooled off quite a bit.
It has.
We're not having any grid issues. Temperature is 68 degrees right now in Central Texas. And I just came from a whirlwind tour of Dubai, Mumbai, Florida, Orlando, Miami, you name it. There's a lot going on. And it's really fascinating to see all the activity that it's happening. And we wonder, what's going to happen. That seems to be up and up after the election. There seems to be a ton of activity. A lot of people preparing for 2025. And it strikes me that, today we're going to talk about what's going on in workforce development and research and the academia world. And Johnny, I know that, UT Austin and A&M and obviously Texas State, where our guest, Dr. Semih Aslan, comes from, that all these places are bursting. I just can't imagine the level of excitement, innovation, energy. I mean, what's your take?
Well, my take is there's a big question. Given the election, what will happen to those things that are already in progress? That is, if you look at what America does right, the question is what will happen to those things? Whether it's the military, well, of course, you cannot do a great military unless you have women soldiers. I can tell you that, because I was on President Carter's group committee when we switched from the draft to the volunteer force. Whether it's how we deal with education, will the Department of Education, will they seek to redesign it or indeed delete it completely, get rid of it? To the issue of immigration, what will happen to immigration? Is it about immigration in general? Is it about illegal immigration? To the issue of what's going on in American communities since there's been an election, there's a lot of stuff on anti-Semitism that's been reported in the press, which is a continuation of things. So, Andreas, what's happening here, if we look at the economy, we know that we have a great economy, and the question is what will happen at the structural level to change what we do? Will we be limited at universities to our great students that come from abroad? And those students are not coming from the West anymore, as they did prior to the 1970s. They're coming from the East, and they're coming from from India. They're coming from Japan. They're coming from China. They're coming from Africa. So that's a change. That's a change in where the students are from. So there's a lot that people are talking about, and the big question is, given what we are doing now, will it be changed in a radical kind of way? But if you look at all the indications of what we're doing, then as we said last time, above that cloud, there's a sameness of of the idea of a threat to the workforce. What will AI have on the workforce? how we continue to train students. We really don't want to change American universities and colleges into trade schools. We want to have a place of learning where you can learn how to learn and learn how to do stuff. So there's a lot going on, I think, in the context of, hey, we're doing this right now. How will it change with the next administration? Otherwise, there's been a lot of talk about the economy in my world. Startups are as strong as they've always been. The bio startups are out of sight, out of really going strong. The economy, it looks to be picking up. Texas created 4 times again the amount of jobs in any other state in the union, and so, and I think there's an interesting commentary on whether or not the truth is being said about the economy and where we go from there.
Yeah, yeah. Llewellyn, what say you?
They're fixing what isn't broken in the military, in our health system, in our research, in our education. These are the target areas of the new administration, and they've declared a problem where there doesn't always seem to be a problem. For example, women in military do not represent a problem. You're going to have a lot of problems though if you destroy the system of generals and people appointed. If you start criticizing and even court-martialing generals for no special reason, you're going to demoralize the whole military establishment, and that's a very dangerous thing to do. In research, we have a chance that, and the very cusp of huge breakthroughs, particularly using AI in medicine, we will see a regressive stand or a regressive movement where a lot of people from NIH may lose their jobs or said to be about to lose their jobs. All of the energy will go out of medical research. If you put the person in charge is basically hostile to that endeavor. Same thing applies across. With education, this is the most threatening of all, because if this education becomes entirely the responsibility of the states, those states that have got bad schools now will have worse schools, and those like Massachusetts that have pretty good schools will take great care of them. So an imbalance which has really lasted since the end of the Civil War will be perpetuated. This all seems to me unnecessary, dangerous, destabilizing, and eventually will impact the economy in a very negative way. Very much the same thing applies overseas. Nothing has worked better almost in human history in terms of alliances than the North Atlantic Treaty Organization, and yet it seems to be facing some very bumpy periods with the new administration coming in January. The only person, though, I will say, who seems qualified for the job is possibly Marco Rubio as the Secretary of State. Otherwise, it seems to be this disconnect between qualifications and job. You wouldn't ask a passenger to land an aeroplane, and yet that seems to be what is going on in the appointment of the cabinet, the new cabinet, which will come into power next year. If you don't know the subject, it's very hard to know how you're going to reorganize a large, complex, and sophisticated bureaucracy. You're more likely to do it badly, clumsily, and with a high price than if you did it skillfully and with a scalpel. But you cannot handle a scalpel without some training in that delicate instrument.
Okay. Well, the question becomes, all these opportunities in front of us, and I wanted to us to hear from Dr. Semih Aslan, and before we jump in, I wanted to make sure that we all knew that Dr. Aslan is an associate professor and program coordinator of electrical engineering. Oh, I would call that the chair of the electrical engineering department at the Ingram School of Engineering, and director of the systems modeling and green technology lab at Texas State University. It's a pleasure to have him with us for an hour or so to talk about what's going on with the workforce, undergraduate, graduate, the number of jobs and opportunities, and the kind of research that is happening. Before I jump in and say hi, I want to remind you all that Texas State has a campus on North Austin and in Round Rock, and a campus in San Marcos. So it's kind of sandwiched in between Round Rock, Austin, and San Antonio. And within that geography, you have a significant number of electric utilities: LCRA, Austin Energy, CPS Energy, Blue Bonnet, New Braunfels Utilities, Guadalupe Valley Electric Co-op, San Marcos Utilities, and the headquarters for the grid in Texas, ERCOT. And so within 100 square miles or so, you have a significant number of technology companies also that surround all this growth infrastructure. So you got auto industry, Toyota, Tesla, a bunch of third-party companies. You got Continental. You got a lot of manufacturing hubs. You got obviously stuff that is going on with the space economy, SpaceX. A lot of companies that are dealing with the advanced air transportation sector and the autonomous vehicles and all that. So with that said, Semih, say hello and tell us a little bit about what you're working on and what's going on at Texas State.
Again, thanks for inviting me, and hi everybody. My name is again Semih Aslan, and here currently I am in my office right now in San Marcos, Texas. We are 20 miles south of Austin, but right now the way that city is actually right now like suburb right now when you look at that way. We are really close. As Andres said, that we have a good working relation with the companies around us. We have many different companies in Austin and San Antonio and San Marcos itself, including Amazon. And also, we are trying to expand in terms of Texas State, especially electrical engineering. Currently, we are trying to create a satellite company. The way that everything is happening right now in Texas, we are trying to reach out to our students rather than they come to campus. So we are trying to create a satellite campus in Allen, Texas, under Collin College. And also another one is we are trying to do Texas Global is trying to have a Texas State at Mexico. So we are trying to grow, and currently our student number is over 40,000 as a university. And engineering is also currently have 5 programs. Electrical is one of the largest. Mechanical is the largest actually right now. And mechanical, electrical, civil, industrial, and manufacturing. So in that one, and electrical engineering, currently we have a undergraduate program, and we have 3 concentration: computer engineering, micro nano, and then networking and communications. We have a MS in engineering, but hopefully we'll be starting our PhD in an electrical MS in fall 25. So it's not just the Texas area, as we know that especially Austin area, capital area, is growing, as well as university going parallel with that in engineering as well. Currently in my study, I am working on renewable energy, and also I have research on high performance computing, microprocessor, and signal processing, image processing area. And I have a smart lab, and what we do here in smart lab is try to figure out how we can integrate AI and ML in power. And we are trying to work on the fault detection, how we can actually implement, and we can do renewable energy load forecasting. So we also work on some NSF project with the rock identification using machine learning and for the drilling companies. And also we have a couple other things that passenger identification systems for companies in Austin area. So we are really lucky that we have many different companies around us. They actually help us to grow, as well as they help us to create new projects, sponsor our students, and as well as fund our research. So, and some other faculty members are also doing research in due to CHIP Act. Right now, currently, we have a great semiconductor research facilities and also faculty members. And also we have a good amount of network and communication faculty members that working on 5G, 6G, and as well as some of the other areas in networking. So,
All right.
Well, Professor,
Johnny?
yeah, let me ask you this real fast. I'm asking you two questions. One has to do with the discipline of engineering itself, that is the mechanical engineering versus electrical engineering. I think that if you look at the grants that's coming out, that the number of grants for electrical engineering is going up, while the number of grants for mechanical engineering is going down. And what's the implications for companies as you guys combine the research and help companies? And the other thing is that if you when you look at, let's say, Central Texas, and look at the need for engineers in the future, where are they coming from? Or where are your PhD students coming from? What kind of contributions are they making in the real world? Do you recruit them after they have worked a while, or are they coming right out of undergraduate school for PhDs for research to enhance company growth?
Right now, when we look at our student population, I'm talking about heavily in electrical, and then I will also give you some idea about the other sides as much as I know in their numbers. But our current students, which in the opening, what you said about the certain difficulties recruiting students from international locations, really strong with engineering, such as Greece, for example, really great with their signal processing and communication systems. Students, for example, in Turkey, the great power. I am from Turkey, and then I have also a power background from Turkey. That's one of the area that we have a good research areas. And also England and the Europe area, and then also some of the Asian countries. It's getting a little bit more difficult because other countries are also competitive with their PhD. And when you look at, for example, now job, you might see actually some of the countries like Denmark or Germany is looking for PhD students, and they are giving good money for them and to actually select those countries. But still, we actually get our students from different regions. We get a good amount of students from Asia. We have from China and heavily from Nepal. We have Bangladesh in India, and in Europe area we have students from Turkey, and we have students from some other areas. But also we have a good amount of students from Texas. Our students actually try to stay because the job market in Austin area is really great for electrical engineering. That might be the reason that you are saying the number of mechanical reducing compared to electrical. Austin area is really great in terms of the number of jobs for our graduates. I mean, there is right now, when you look at it, around anywhere between 1,000 to 2,000 jobs that you can actually find every day in Austin area in electrical engineering. So that's a really great number. And that's actually, I don't have any students after their graduation. They like, I need a job. Can you give me a recommendation letter? And most of the recommendation letters comes when they ask is if they want to go to graduate college or PhD programs or something like that. I mean, that is a really good news for our students, for our graduates, but that also becomes a problem as well for our recruiting. So for example, if I want to recruit a really great student from undergrad to master's or PhD, but they want to go to the companies because it's really challenging in terms of the offer they receive from those companies in terms of salary. So, but our students are right now heavily coming probably around 30-40% US, and the rest will be most likely around 30% Asia, 40% Asia, and then the rest from anywhere else. So we have from African countries, and so we are really kind of diverse in that level.
And do you see a cross-disciplinary approach at all with the biological sciences and electrical engineering? Like I'm working with well, I know a group in Minnesota, and they're putting sensors on cells in the human body. You know,
Uh,
so do you see any collaboration of with the nanotech stuff, for example? Because it seems to me that that people in biology are using the same techniques in nanotech that engineers have used for years. As that
yes.
skill level is switched over to biology from engineering, as they try to engineer, quote unquote, the biological elements in society. Do you have any crossover at Texas State?
Unfortunately, we don't. I mean, as I said, we are still growing, and the program itself is a new. You can call it around probably around 17, 18 years, but still growing in terms of, and also we are a state university. Everything that we do needs to go from the different steps, and but that's another area that we want to focus on. For example, one of our hire that we were trying to bring here has the medical background, and you know, because we would like to make sure that we actually get into that area and use the sensor and nanotechnology development in healthcare or other areas of the biology, and that's including using different type of sensors and then using the biology and electrical engineering or engineering, how we can actually approach that. But we are planning, that's in our the future plan, in 10-year
Yeah,
plans.
there's one other question that I have here. What's the distribution of grants from basic research versus grants from companies themselves?
I can answer. I mean, in terms of we have right now, when we look at our expenditures coming from the federal government a lot. For example, civil engineering just received a $10 million grant from Texas, the Department of Transportation, to create a center here. And also we are just getting another grant from DOD and also CHIP Act. And we have a good amount of, I think I can say around 80-90% of them are the federal funded projects, and probably 20-30% and probably around the companies. And but also some of the companies, what they do is they actually help us to do the research with some type of in-kind donations. And so that's another thing that we can actually say, that some companies, for example, donates $500,000-$600,000 equipment for our research, and then we can actually take it to that next level, or they support us with the federal grants. For example, companies supporting the DOD and the research that we have with their in-kind or their support with their equipment or some other things. So I mean, there is this kind of the support comes with that as well. So
okay, thank you.
Llewellyn?
Is there a surge in students taking engineering? Is it a hot subject at the moment?
I mean, I think the hottest topic at the moment is AI and ML, and currently it is one of those areas that we are trying to actually work how we can implement to the different areas. For example, how can we implement ML in the power? How can we implement ML or AI into networking? And for example, as I said that my background was not machine learning, but I had to actually get into it because of some of the trend is going in that direction. How can I actually implement what I know for my signals and signal processing background and communication background? How can I implement the machine learning? We actually got a grant from NSF trying to identify rocks and densities as well as their chemical properties by using the machine learning and some type of XRF sensors, and make a decision based on their pretties and so on. So we are trying to adapt that way. But I think I can say that definitely right now the hottest topic is in AI and machine learning. So
isn't it a fact, Neil, that the two sort of base disciplines of electrical engineering and mechanical engineering have always been like an authorization to do anything? I find electrical engineers doing things quite far from electricity, and likewise mechanical engineers. These are just very useful general qualifications. Are your students aware of that?
Oh, yes. Especially if they are taking class with me, they are definitely aware of that one. Because sometimes I use myself as an example where, I started as an high voltage engineer and I did research on electromagnetic field analysis on cables. And when I was working and then work as a transmission line engineer in Turkey, and then I came here and then did my master's in Chicago. And then I was working on heavily in power amplifiers, and then I did my PhD in computer engineering. So I reduced the voltage level, but again, I went away from the voltage as much as possible, and my research turned into me more and more analyzing the systems, how to improve the current systems and the processors, all the way down to the implementing some of the algorithms optimizations and so on. I think it is correct that what I can say right now, almost a big amount of the electrical engineers are not dealing with electricity that much in a way. That's definitely correct. And so
With your background, what do you see as the challenges in the electric sector outside of generation? In transmission, for example, will new technologies enable us to carry much more power over the same right-of-ways, if not the same lines? I'm thinking about various improvements, quite dramatic, some of them, in connectors, better connectors carrying more use of DC current to move large quantities of current. What do you see as the non-generation revolutions taking place in the electric sector?
I think it's not in my area, but I think one of the biggest area is going to be battery area, and because of the storage that we are going to need in the future, and also how long it's going to take to actually, for example, for electric cars, 300 to 1,000 mile improvements will be a big deal, and but in terms of what we look at it is, I think one of the improvement in terms of, again, this is a totally personal opinion, that is going to be 6G and implementation of 6G in the smart city concept when we look at it. And then also everything will be connected, like connected cities and then connected feature, and will be, in my opinion, again, the next level of a big deal. So again, it comes to one of the other things comes into the 6G, the machine learning and AI implementation and the networking. So that's another big concept.
As my last question in this series, I wonder, what are the impediments to students going into engineering? Often students don't go into a subject because they presuppose they're not qualified or not likely to excel. For example, if they're not absolutely brilliant at math, they may not understand that they could still have a career in engineering. These barriers that often little more than folk tales establish and direct people. I spent a lot of time talking to different engineering schools about the false barrier between the science, between liberal arts and the hard studies. We have an expectation that engineers can't write. I've not found that to be true. And an expectation that people who have literary tendencies cannot be engineers. I happen personally to think that the poets of our time are engineers. What do you think about the old C.P. Snow argument about two cultures? What do you think about it? Are there pre-expectations that kids are given when they're quite young that divert possibly talented people from going into engineering and the sciences?
I think it needs to be going to maybe high school, even earlier than high school, even it needs to go to maybe middle school or elementary school level. the training. Let's say it that way. So I have a son that I actually observe how actually he makes his decision in terms of his behavior, and he's really good with math, and he's you know, a sophomore in high school. Even before, he was always wanted an engineer. So that's one of those things that when somebody was looking in what you want to be, the college either it's a 3 or 4 high level, because you see a lot of doctors, you see a lot of engineers in TV. The kids have that type of look. But when you actually get into the talk to the engineers, or when you talk to the other group of people, and my son is talking to me every day about the engineering. He comes to school, he visits me, and then he actually gets the better understanding of what it is and what it does, and what level of math and what the level of hands-on it requires. Because of that, I believe that the most important thing is the outreach programs, and we do outreach programs at Texas State University quite often. So we actually go to high schools, and in rural areas, we Lockhart, or I did some funded work with USDA to actually you know, introduce to engineering to our students in rural area high schools, and we can actually see what students don't know exactly what's in engineering. And there's another thing that also what they think is a really heavy math oriented, but they don't understand that there's also creativity portion of it. So you actually have that when they see actually some of the hands-on project, we do a lot of hands-on. Are one of the biggest you know, positive thing in Texas State is most of our labs are hands-on, that students actually need to create. And then also we have a senior design project. The students actually create a project with help of the faculty mentor and industry mentor. And then this will take 1 year. And some of the high school students or middle school students comes and then see that process, and they see that it's not just math, it's that creativity comes in. As you said, it's this kind of art level. You know, sometimes you need to see the patterns in creating a project. And I think those are the big impacts. And one thing that I say is, for create the future engineers, I think we need to go to really early levels of students' education, introduce them what's in engineering, maybe some of the projects, implement them in that level, middle school or high school level, will be really good for them to see what engineering is. So
If I just permit me one more question, which I forgot. What percentage of your students are women?
that's a good question. In terms of the percentage, if I want to give you around 12 to 15%, and this is one of the big headache that I believe everybody has, and not just Texas State, when it comes to increasing the number of women population in engineering. But I actually did a research in 2014 with USDA and Intel here, and that was a part of the grant called Women and Minorities in STEM. And in that research that we saw, and one of the reasons that students, especially female students, are not going in engineering is a couple of those reasons. One, that the mentality is they are heavily where they are going to work, like as you just said, if electrical engineer, their idea is they're going to work with electricity in the big power plants, but as we later on discuss with them, that almost 60-70% will be actually different areas. Or another thing is heavily math oriented, difficult, and is a man or you know, dominated area. So we try to actually break that, but that's a big problem. And also it's a big problem in our faculty numbers as well. We would like to actually improve that number as well for female faculty to increase. Our female numbers are better than our students in terms of the female faculty member numbers, but that's one area that I can say that everybody actually, every universities in the US needs to have some improvements.
That's another area where you're fighting cultural pre-selection. Thank you very much.
Johnny?
Yeah, Professor, let me ask you this. I think that when I look at stuff, I think if you look at the rapidly, the evolving issues of 3D printing, AI, the Internet of Things, all of these issues have had a big impact on engineering. That is, how to ground them in the things that engineers build, including buildings, by the way. So my question to you is, when you look at it from an academic point of view, and you look at how these things have changed enterprises, and of course they're going through engineering. I mean, how have you handled that in terms of the hiring of faculty, what people are doing research in? The Internet of Things will have a big impact on how we do engineering, and AI will have a big impact on what engineers do. And that's in the whether you're building houses or building roads or building bridges or whatever have you. All right, so when 512 CMG looks at smart cities, we're really looking at interacting with what engineers have already done. But when you build in, let's take 3D printing, right? Or let's take AI. I mean, how are you dealing with that in terms of integrated with the curriculum, or do you go to computer science to take that and then bring it back? Because remember, to me, electric engineering and computer science, in terms of the business world, have really, really converged in an interesting way. So how are
Yeah.
you handling that?
No, that's a great question in a way that one of our challenge, when especially we are trying to teach our students, and also when we are trying to implement new technologies, and then also try to implement new ideas. We always update our curriculum. That's one thing that we do. We used to do every year. So every year we used to update our curriculum, and then following semester it was actually, for example, you do it now, and then the fall 25 it updates. Right now we actually increased that to 3 times in a year. So you can actually update the curriculum 3 times, because it's becoming such a dynamic changes, and sometimes you have to do monthly changes in certain updates. One other thing also we have, this is the lucky portion that lucky thing that we have, especially for me as a program coordinator, where I need to create the schedule the classes and everything. We are really lucky to find the adjunct faculty members from industry, and also that brings up a lot for our students, what's happening with the companies in new technologies into a classroom. So we have, for example, I can say the name, I can say that a faculty member from IBM teaching VLSI class. And we have another faculty members coming from AMD. And then these are actually helping students to understand exactly what new technology. For example, when I teach VLSI class, when I learn 9 nanometer technology, but when you're actually taking from somebody currently working on a project with the 7 nanometer technology, and then the new 3D FinFET, and it's a little bit different to actually get the information from them compared to somebody's doing it, but not into the research or not into the what's happening in the industry. So that way, we have a good amount of faculty members from industry, and also we are updating our curriculum heavily. And another thing is also we are updating new courses. We are creating new courses. For example, AI course that we are creating, and for our PhD program, we actually have a computer engineering and AI concentration. That's what we propose, and these are something that we are implementing the new technologies into our curriculum. And one other thing that we have a maker space in our building, has around 40 3D printer free for our students to use. And as you were giving the example of a 3D printer, our students can actually, they go to senior design, whatever idea they have in their mind, they can actually turn that into a product using the 3D printers. Or there's some other things that we have, like for example, water jet cutter, if they have something a little bit more, difficult to cut and so on. I think that what we have as a technology in the university is helping our students to catch up with the what industry requesting or requiring, and as well as we have the faculty members knows exactly what's happening as well. So
Semih,
Okay, Yeah, one other thing, I've always said that, engineering solve problems, right? Use science and mathematics to solve problems. Hey, those problems are now going to where? They're going to the material sciences, right? That's changing rapidly, right? They're going to physics and fluid mechanics, right? That's changing rapidly. So the great thing about, I think, engineering is that learning how to solve a problem.
So,
And I think from an academic point of view, it might have come from physics to solve the problem. From an academic point of view, it might come from material science to solve the problem. It is one of the few disciplines in the university that really cannot put walls around itself.
yep.
I've always said that. Yeah.
Yeah, Semih, I wanted to give you the opportunity to talk a little bit about senior design. And I was gonna share my screen here so that everybody could see about senior design. So this is a program, capstone type program at the Ingram School of Engineering, hosted on a yearly basis. And you have first semester projects, second semester projects, and December 6th is the date for this semester's program. And this is the page at the website, and you can register to attend. And it's some 50 projects or so. You got civil engineering, first year, second year, electrical engineering, industrial manufacturing. So when you look at, for example, the electrical engineering projects, you can see here stuff around integrated camera and lighting system optical optimization, ACTS project, PCB Innovate project, urban hotspot, San Marcos Heat, Navibot, King Aegis. So anything you want to share, Semih, on what's going on
Sure.
here and the importance of this?
Sure. We are really proud of our senior design, the way that we created. I can take the credit on that one a little bit in terms of electrical engineering, because we actually have a really the electrical engineering started the senior design project in 2 projects per year. So what we have is every semester we have a senior design day. As you see that the next one is going to be December 6th, and everybody's invited. So it's open to anybody will register, and then they can come and then look at our projects, and also they can try to interact with the students, ask questions, and see what's happening. And our students will present their project as D1, which is the first semester students. That's what we call them. And then D2, which is our second semester students. So second semester is when they complete their project, final project product will be actually presented, and then hopefully they will be graduating after that point. And then every project has what we have a class that they learn how to create the functional description, and also they create the ethics, what are the important portion in a project they need to actually work on. And every project is a sponsor, and we have sponsors from NASA and different companies. And then also we have a faculty assigned to each one of these projects. And so we have a faculty teaches the course, faculty mentors the students, and also we have a sponsor gives the project and also advises students based on the description or based on the outcome they want from that project. And also we have an IAB meeting of these projects. Students can actually interact with our IAB members, and that's a good way that we actually brings the company industry with the student projects. But our projects are, as I said, publishable paper. So that's another thing that we are trying to actually work on. Every project is a publishable quality. And so that's something that we are working next level. We published few papers, but we want to make sure every one of them is publishable. So that's another thing that academy is trying to do, publish papers. So, and so these are all undergrad level projects. And also one thing that I forgot to say, during the class, students are also assigned graduate students to advise them. So we are also training our graduate students to advise on these projects as well. So
Yeah.
Yeah, you know what has always been a mystery to all of us in academia is how we do comparatively with other countries, with other schools. And I'm not a believer in the rankings of newspaper rankings like U.S. News and World Reports. You know, as an academician, I rank universities on their contribution to society, not people filling out paper stuff for a Newsweek. So my question to you is, as you think about the discipline and you go to conferences around the world, or indeed in America, where do we stand in terms of competitive engineering programs? Are people keeping up? Are we still leading? Is France still there? Is England still there? What's going on in China? What's going on in Taiwan? What's going on in the Soviet Union? Because I think one of the biggest things that happened in the last 20 years, or maybe 30 years, was with the decline of the breakup of the Soviet Union, and a lot of the scientists came to America, or indeed they went to Israel. So how do you look at engineering in its totality now? How do you define it in terms of where we are to solve problems in the future for America?
That's one area that we are losing some edge in terms of what's happening right now. As earlier I said a little bit that especially higher education, I'm talking about the graduate level education, other countries are catching up and they understand the importance of creating a quality master and PhD students. They're offering them a good amount of options for students to select countries like Germany and Denmark and so on. But one other thing is really interesting to pay attention is number of PhD production coming from China. And when you look at the 1970s, US always a good amount of high amount of PhD production. And Germany is always in that level, is a high level in Europe. But they are steady. But what happened in the last 10, 15 years, the Chinese PhD production is probably right now, I don't remember the last numbers, but past US. So this is one area that I think other countries are paying attention, not necessarily just creating a workforce like after bachelor's, also creating quality researchers like PhDs. And I think that is one thing that we need to pay attention and make this country, again, really attractive and for quality PhD students to come here and then stay here after that. And this is something that is important. I mean, again, I'm not looking this one as any political level or anything like that. As you were earlier pointing out, this is a really important thing. We need, students, and we need to have that fresh research minds in the U.S. That is something that we are losing. I mean, again, we are losing. Doesn't mean that it's decreasing, but other companies are other countries are catching up. Big amount. So this is something that I can say we are losing the edge, and I see that from the some of the conferences that I go overseas, and also some of the conferences I hear right now. It used to be more U.S. Universities are represented in these conferences. Right now, other universities are actually sending their students to these conferences to actually show what they are doing or learn what others are doing. So I think that is a little bit changing. So I can say that.
Okay, yes, I thought that was my notion too. Thank you.
Llewellyn, any other thoughts?
Yes, I notice in my reporting and my travels, an awful lot of companies seem to be spin-offs directly out of the Massachusetts Institute of Technology. Do you have any mechanism for spinning new companies out of the university? For example, in both fusion and fission, nuclear engineering, there are companies that really owe their entire existence to MIT. I wonder if that's unique to that university. I think Stanford is somewhat the same. I wonder to what extent you're able to establish a relationship with companies founded by your graduates.
Obviously, it's not even close to those schools. I mean, those are the main schools, and then they are, as I said, the years they in this longer, way longer than us. But what I can say that we are actually trying to teach our students what they need to do to not just find a job, also create an idea, and then how they can actually take that idea into a production, create their own companies, be a startup. And I believe one or two of our students did that. And I'm talking about what I know, probably more. This is just for electrical engineering. And also when we write our PhD program, our focus on entrepreneurship as well. So we have an MSEC program, material science and entrepreneurship, that PhD students are actually taking those courses, but we also try to implement that in our students' mind with the curriculum. So that's something that we did. So our students not just taking courses to be a researcher, also they are going to learn how to take that idea into a production and create their own companies. We are working with the business school, and also we are heavily working with some other universities to take our students to the next level. So we are working on that one. And then I'm hope that we will have a conversation 5-10 years later. I can give you much better numbers after this implementation, but we are really understanding that's how important, especially in Austin area, because there are opportunities here. There are a good amount of companies, and also we have a star park that will helping that one as well. So yeah, we are working on that one, but we are not even close to where my dreams are gonna be. So at the moment.
What percentage of your students are from overseas, from outside of America? Not just overseas, but from South America and Central America as well. Sorry, did you hear my question?
Yeah, I didn't hear. I'm sorry.
Oh, yeah. What percentage of your students are from outside the US?
The undergrad, we are heavily US students, especially Texas. So our students are, I can say around 70-80% Texas native students, and then the rest from other parts of the US. But probably over 90% we have national or US students, and probably 5 or 6% we will have international. But that number is totally reverses in graduates. So what I can say that around 60-70% our students are international in the graduate level, and 35% will be US based. Most of them are students. They want to continue with their education and so on. So
thank you.
Well, I think what's important when I talk to my fellow academicians is that I'm in a lot of discussions about education, and there are all kinds of education. For example, I think that one of the things that has influenced my education is music, because I see music as math. I play piano as math. I play guitar as math. And one of the things I always say is, okay, if you don't want to do this, what about ignorance? But we have to realize that in the context of learning how to do things, and this is what has changed for me, with things like Facebook and things like all the places you can go. So if I want to learn a Bach piece with classical guitar now, I can just go to YouTube, right? I don't have to pay, I have to pay that $45 a minute, right, to do that. So how do you see us embracing education in the future and continuing the importance of education rather than ignorance?
it is now when we look at this is another great question, where sometimes I see somebody ask me, hey, in the family members, look, I didn't go to university, but I'm making good money. And I think what I look at the university life, and then after that, it's not just finding a job, or it's not just finding a better job, being a better person, in my opinion, again, because you are not just learning the topic that you are studying, you are learning problem solving, you are learning how to live with others, and you are learning, how to overcome certain problems. And when I was in Turkey, when I lived in Istanbul, when I was studying, I was away from my parents, and I learned the best things that I can learn in 4 years than later lives. I mean, because I became the who I am right now. Uh, I think that that's what the university is. That sometimes people don't see it is necessary, but you cannot just learn those from YouTube or from anywhere else. I mean, you can learn how to, for example, code just looking at the YouTube, but you won't be able to actually solve the problem or approach the problem as a group or with introduction of somebody. And sometimes, especially during the COVID, we did, almost a year our courses online. And what I saw from that moment to the next, our students actually suffered because they missed that eye-to-eye contact. And for example, when I teach, I look at their face and then I can actually see their problems that they need help. And I think that's something that we need to have in the education, that face-to-face contact, that the friend-to-friend help, peer-to-peer help. I think those are something that we cannot replace, and those are really important.
And I think that's important too, because remember in early America, that was only for the elite.
Yeah.
It was just for the elite. It just was. And then as universities spread out, yeah, I agree with you. Everybody should not have a quote college education, and they can make it well. And when I say that, we have to balance that with the elite, the traditional elitism of college and universities for the upper classes in America. That was standard for the Ivy League, by the way.
Yeah.
The Ivy League was started by merchants for their kids, not to necessarily get an education, but to interact with people of their kind. And I think that what I like about what we've done over the last 60 years, there's been a broadening base for education for Americans, but I also see a general reaction, if you will, against that broadening base, because look, all education is distinguished in its own right. Right, whether it's learning how to play guitar, and it's all transferable, right? Whether it's learning how to engineer software, and you pull from different experiences to do that, including that the people that you've met and you've been influenced by. Okay.
Also, one other thing I can add into that one is, as we were just talking, Llewellyn is asking the question where the MIT and Yale and so on that creating those startups. When you look at again, somebody with the really self education can actually be creative. And there are people that didn't go to college and university and create companies. But many of them, many companies out there, when you look at it, comes after the college or comes after the graduate study. And the reason for that is, again, that you take the knowledge, you take the organized learning, and as well as you have connections. You actually connected with the companies, and you actually connected with the people, with the faculty members and with researchers much easier than you can actually do from your home and study from YouTube. And I think those are some of the things that what university can also bring, that connection that you need between the faculty, researcher, and then also the industry. So.
Absolutely. So Semih, real quick, semester is coming to an end. We're out of time. What's in front of you here? What happens at Texas State? What are you working on the next 6 weeks?
So we have a senior design project, as we were saying earlier, and also we will be working on our PhD program passed through the Texas Higher Education Coordinating Board, and we will be working on courses, and we will be working on our research and my own research as well. So I will be working on a couple of projects with the city of San Marcos. And we are trying to work with IEEE Futures Network and I'm also part of that. We are trying to create a connected agriculture, connected farming, connected education. So and I'm keeping myself busy with those at the moment, but I'm working on a couple, hopefully, good projects with the city of San Marcos. So that's the next thing that I'm going to be working on.
Okay. Okay, any final thoughts, guys?
I think it's very interesting. I hope we get a chance to meet another time, Semih, and very interesting.
Johnny?
They're very interesting, and I think that the issue of education will always change. I can remember when I was way back there when I was in elementary school, and they were saying, "Oh, television is now color. We don't have to go to school. We can just have everybody have a television at home and work." And I think that what we keep in mind is that the interaction of what we call an IC square, think and do. We must always learn to think, but also apply that knowledge to larger society, whether it be education, whether it be engineering, whether it be political science. So I always said that to think and do. I've tried to live my life by not just thinking, but in my case, building companies, not just being theoretical about music, but also playing, classic guitar or any kind of guitar. So I really enjoyed the conversation today, and keep working at Texas State, the alma mater of Lyndon Baines Johnson, with the prettiest campus in the state. Yes, sir.
And again, please come and visit us. And December 6th, we have our senior design, and you'll be my guest. Anders will be there, hopefully.
Okay.
And please come and visit us. So
Absolutely. Johnny, take us away.
Okay. In the Southland, there's a city way down on the river where the women are very pretty and all the men deliver. They got music playing all the time. Starts in the morning and go all through the night. And when you hear that music playing, it's gonna be all right. Thank you.
Thank you, guys.
All right, take care now. All righty, bye-bye.
thank you very much.
Bye.
Bye.